So in this, we will be discussing about the SOP as well as POS. SOP means sum of products. You can see here. Yes, SOP, sum of products form, you can see in that. So in Boolean algebra, we have two different types of representation. You can represent the Boolean expression in two different form. One is SOP form, another is POS. SOP is sum of products. Look at this Boolean function. Here you can see this is the product function, and this is the product function, and this is the product function. And you can see sum of this product function. So this product function, in between you have some symbol. So it is sum of the products. Sum of the products. And what is the thing in how we represent logic 0 in this? Logic 0 is represented as A complement, and logic 1 is represented as A over here. And in SOP, we use summation as the symbol to represent the minterms. Always SOP is related to minterms, and we use this summation term to represent the minterms. What is minterms? So this, all this are the minterms. So what is the value of this one? It is A, B, C, nothing but 1, 1, 1. And this is A bar B, C. So it is 0, 1, 1. And this is 1, 1, 0. So what it is? 1, 1, 0 means it represents the minterm 6, and this represents minterm 3, and this represents minterm 7. So I can represent this SOP as summation of 3, 6, 7. This is the SOP representation for the given function. In the same way, POS, product of sums, you can see that you have each literal is represented as sums, and you have the product of this. Bracket means you have the product of that. Now, here you how you represent logic 1. Logic 1 is logic 0 is A, and logic 1 is A bar. In case of POS, that is product of sums, we represent logic 0 as A and logic 1 as A bar. Now, how we make use of, how we can represent this with the help of the symbol? We use pi symbol. And for min terms, we choose small m. For max terms, for POS, we call it as max terms. So here each term is the max term, and we use this pi symbol for that. Now, as logic 0 is represented as A here, so it is 0, 0, 0, 1, 0, 0, and 0, 0, 1. So 0, 0, 0 means M0, 1, 0, 0 means M4, 0, 0, 1 means M1. So pi of 0, 1 and 4 is the SOP function for the given Boolean function. This is the way you can represent, or this is the difference between SOP as well as POS. SOP is always dealing with the min terms. POS always deals with the max terms, And here you can find sum of products. You will be having lot of products there, and the sum of those products will be there. And always A bar represents logic 0 in case of SOP. But here you can find product of sums. You will be having individual literals in the with the plus symbol, and the product of those can be found in case of POS. Logic 0 is represented with the help of literal A here. Complement is represented for logic 1 here. And the symbol we use is pi for POS, and the term is max term. So these are about SOP and POS. Here you can see the a table which is having min terms and max terms of three binary variable. Here you can see starting from 0 to 7 all the decimal combination and the terms how you have to represent for this is for SOP, and how to represent for POS and their designations. You can see that initially 000 means X bar, Y bar, Z bar. Designation is M0. The same thing you can represent using POS. Since it is 0, it is X plus Y plus Z, and the designation is capital M0 since it is POS. So in the same way for all the values from 0 to 7, because 3-bit representation. You can see here one more example. If I choose 6, it is 110. So X, Y, Z bar in SOP means M6, and in case of POS, 1 means X bar plus Y bar plus Z. M6 is the capital M6 is the representation for POS. Now, consider a function. Two functions are given, f1 and f2 in the truth table. So, function f1 equal to, wherever you have 1, that will be, the function is present, or function is true at that case. So, you can write f1 equal to 1 is for, this is 0, 1, 2, 3, 4, 5, 6, 7. So for 1 it is true, for 4 it is true, and for 7 it is true. So min term is 1, 4, 7. And for the function 2 it is, here it is 2. That means 3, 5, 6, 7 it is true. So M3, M5, M6, M7 it is true. So these are the min terms for the function. Now to find the F1 complement, you can directly write the remaining terms. Like for F1, what all missing here? Which are only 1, 4, 7 is present. Rest everything is missing. So if you want to write it in terms of max terms or POS form, you can write is M0. M1 is present here. Next, M2 is missing. M3 is missing. M4 is present. 5 is missing. 6 is missing. And 7 is present. So this is the representation of POS. For the same function F1, in the POS form, you can write in this way. For similar way, for F2, 3, 5, 6, 7 is there. So what is missing? M0 is missing, 1 is missing, 2 is missing, and 4 is missing. So this is the POS representation for F2. Now, conversion between the canonical form. A question is given, f of a, b, c, d, summation 1, 4, 5, 6, 7. Now, f complement a, b, c equal to summation. What is absent? What is missing over here? That is 0, 2, and 3 is missing. So I can write in terms of min terms here. Now f equal to 0 to 3 complement m0, m2, m3. I can write 0 to 3. Directly I can write pi of 0 to 3. So whatever missing to convert it into conversion between the canonical form. If you want to convert SOP to POS form, given SOP, identify that, and whatever missing literal you have to mention with the help of pi symbol. Since this way you can convert it. This is about the canonical forms.